Good morning to all. Uh, in today's session, I'll discuss about the timestamp based concurrency control. Uh, this is one of the let's say extension of concurrency control mechanism. I hope you remember that the concurrency control is used to maintain consistency of read write, write read, WW conflicts. Let us understand what is timestamp based concurrency control first. Timestamp ordering is a concurrency control technique that uses timestamps. So it uses a timestamp mechanism to order transactions. So it uses the timing convention to check whether there is a conflict. So if there is a conflict, there are some measures to overcome it. So in case of previous one, we have used lock-based concurrency control. In lock-based concurrency control, we actually lock a particular region either by using shared lock or exclusive lock. But in timestamp ordering, we use the timestamp. Okay, we use the timing concept to check whether we can ensure serializability. So the prerequisite is for each transaction, a unique timestamp should be allocated. So I feel the meaning of a timestamp is it includes date as well as time. So which determines the execution order. So what are the key concepts? So TS of T is a symbolic representation indicating timestamp of a particular transaction T. So whenever you write any data item, so we try to have, okay, let us assume that the object is X. And if you are writing for an object yes, then we record a timestamp of it. That timestamp is referred as W underscore timestamp of X. Or it can be represented as timestamp of last write on X. So we try to maintain it. So if some other transaction does it, then fine, a new timestamp will be written for that particular object. Similarly, when you are reading it, you also record the time. So it is referred as read timestamp. Okay, so it is a timestamp of the last read on object X. So how do we follow the rules? Okay, what is the procedure that is used to maintain concurrency control? If at all, if you want to read an object X, then the rule is very simple. The rule says that TS of T, so timestamp of the transaction, which started, should be less than WTS of X. If that is the case, then you are supposed to abort. So indirectly, you are avoiding read followed by write conflict. Let us assume, okay, I'll show you with one more example. Just imagine that TS of T. TS of T is the starting time of the transaction. So you're just comparing it with somebody who has already written, okay, something on the object. If this is, let us assume that, okay, 10 a.m. and okay, this is 11. Okay, so it means that okay, during your time of execution, somebody else has also already written it. So if that is the case, we abort the transaction. We abort the transaction. Else we allow it, and okay, so and we update RT. See, the read RTS and okay, the WTS timestamps is universal. Okay, it's not written. Okay, it's for an object X. It's not for a transaction. See, let us assume that there's transaction T1, which writes an object. Then fine. Okay, the time will be recorded at what time it has been written. So there might be okay one more transaction. Let us assume that T2. T2. Okay, so will write some other object. If there is some other object, okay, Z, then once again the timestamp for this will be different. Timestamp will be different. So you should remember that. You should remember that. Okay, the timestamp is okay. The TS indicates the timestamp for a transaction, and W indicates when the object was written by any transaction. It's only it's not that you're specifying this particular transaction. It can be any other transaction. So what does this says? It says that if the timestamp, okay, if at all, if the timestamp, it means that some other transaction is there. Okay, you try to read an object X. Okay, when you try to read an object X, you are checking whether Ts of T, whether it is less. Okay, if it is less than WTS of X, so then we abort it. Okay, so it means that there is a read-write conflict or write-read conflict. So both of them is been overcome in one single exercise. So if I go for the other one, okay, I'll show you with one more example. Okay, so when I go for a rate of x, I go for a rate of x if Ts of t, if it is less than Rts of x, so timestamp of the transaction is less than, okay, is less than, okay, Rts of x, that is read time, okay, read time of the transaction, or timestamp is less than the write. If, okay, if both of them are, if it is less, then we abort a t. So, okay, else we allow the update. So I'll show you with some examples. So then, okay, it will be clear for, okay, understanding. So we have a transaction T1, okay, as 10 milliseconds. Okay, it was started at 10, okay, 10 o'clock. Transaction T2 was, okay, started in at, okay, 20 hours. So we have WTS of X, okay, as 15. Okay, now transaction T1 wants to write X. So some other, okay, had written, okay, in 15 seconds, okay, somebody had written, okay, the object X. So T1 wants to write X once again. So what is TS of T? TS of T is 10, which is less than WTS of 15. So T1 gets aborted. So very simple concept. So this prevents, okay, so indirectly you're avoiding write-write conflict. So somebody had already written it. So you wanted to write it. So write-write conflict will be there and hence needs to be aborted. So TS transaction T1, okay, so started at 10. Transaction T2 started at 20, but somebody wrote it. Okay, okay, so but at this point we are understanding that we want to know that whether transaction T1, okay, wants to write some object, the same object X. So I'll check what TS of T1. Okay, when did, okay, transaction T1 started? It was started at 10 o'clock, but okay, it is somebody else has already written it, so it at 15 hours, so and hence it must be aborted, and hence it must be aborted. So this is indirectly you're avoiding conflicts. Okay, you're avoiding conflicts. Uh, so I want to read an object X. So if it is some other object, quite naturally, if timestamp is not available for write or read, then it will allow. That's it. Okay, very simple concept. So in transaction T2, wants to read an object, the same thing will happen. TS of T2, okay, T2, okay, read X. Okay, what is the, okay, hour? 20 seconds. 20 second, okay, is greater than 15. So ordering is acceptable. Okay, so you allow it and we update the timings of RT of X. Okay, is equal to 20. So a very simple rule which has been applied over here to overcome the conflict. Majorly it overcomes WW conflict. So remember those two important points. So the points are, okay, these are the two rules that you should remember. If you want to read an object as TS of transaction of time should be less than WTS of F. If that is the case, I abort it. Else I allow and we update. So it's something like you're ordering it. You're allowing the ordering of execution. So whenever I go for write of it, then fine, this is the condition that I check. Any one of the condition is there. If TS of T is less than RTS of X or TS of T is less than WTS of X, we abort it. Or else we allow it. Okay, or else we allow it. So this is a very simple example which illustrates it. Okay, so the question might be, okay, explain concurrency control, which does not use, okay, locking, okay, which does not use locking. Then I feel this should be the answer. The question is, okay, explain concurrency control, which does not use um, locking mechanism. So this is the answer that you are supposed to write.